Yes. So let us start session. So 8 p.m. batch introduction. So previous class, what is Hadoop and these things, just the basics. Last 3 classes, basics were discussed here. Big data challenges were discussed. Yes, big data challenges in this data processing, data storage, data processing. Next, the high-end hardware. These concepts were discussed up to this completed. Next, very large files, backup and recovery. Next, disaster management. These things required. Now, very large files. Let us see today here. Very large files. Okay. Yes, how Hadoop can handle very large files? Traditional systems can't handle large files. Suppose here, file 50 GB file, 100 GB files cannot. So very large files. Traditional file system like Windows file system or Linux file system. They are traditional file systems. Windows, Linux. These are traditional file systems. Okay. Yes, Windows, Linux. These traditional file systems are not in a position to handle very large files. Very large files, GBs of data, like 50 GB, 100 GB cannot handle. Cannot handle. Okay, reason. Yes, maximum size of the file can be handled by Windows Linux is 60 GB, around 60 GB, not more than that. Yes, in Linux or Windows here, we can create a file with max size 60 GB. More than that, it won't work, it fails. Big data files, 100 GB data file, 200 GB data file, 300 GB data file, that much of GB data for it, that much of GB. Okay, yes, traditional systems can't. Big data files, 100 GB, 200 GB, some terabytes of data also can't. But Hadoop can handle. How Hadoop can handle? How Hadoop can handle here? Okay, suppose there is a 100 GB data file, or 200 GB data file is there. In Hadoop, yes, that file, suppose file with 100 GB, file with 100 GB, file with 100 GB divides into multiple parts, dividing, splitting. In Hadoop, file will split. In Hadoop, file will split here. See, in traditional system, file never splitting here. One file on only one computer. Yes, Windows Linux file system, in this, yes, one file on only one computer, one file on only one computer. Cannot be multiple computers. Okay. So Windows Linux file system, one file storing on only one computer, not multiple computers. But when come to Hadoop here, so what happens? See, this is Hadoop cluster, right? Hadoop cluster. In Hadoop cluster, what happens here? When you're loading a file, that file is splitting into multiple parts and distributing onto multiple nodes in the cluster. Okay, yes, that will be distributed. So name node taking your file data and splitting into multiple parts, and distributing onto multiple nodes in cluster. So file get distributed. In Hadoop, file get distributed. Okay, but in Linux, no distribution concept here. Linux, Windows, file cannot break. Yes, one file on only one computer. File cannot break. One file on only one computer. Okay, so one file on only one computer. Okay, Linux, Windows. In case of Linux, Windows, one file is on only one computer. One file is on only one computer. Cannot break. But in Hadoop, file can break into multiple parts. Those parts distributing onto multiple nodes in cluster. So previous class we have discussed distribution strategy. See, name nodes, file with 100 GB data. When you try to load 100 GB data, that 100 GB data divides into multiple parts. How many parts? Yes, that depends on data. See, what is the distribution strategy here? Distribution strategy, previous class we discussed it. Distribution strategy, see this. Distribution policy here. 5% of total data distributing onto each node, right? 5% of total data. Suppose if it is 100 GB data, so 5% of total data means how much here? 5 GB. Total data 100 GB, right? 5% of total data distributing onto each node. So 5% of 100 means 5 GB. So 5 GB, 5 GB, that means 20 nodes. So one file dividing into multiple parts, storing on multiple nodes. File dividing by distributing onto multiple nodes, it can handle large file also. Okay. See, 1 second.
Hello, sir.
See here. Yeah.
Sir, you have told that that 100 GB data will be divided into multiple parts and will be distributed to the different nodes, right?
Yes, right.
Sir, but you told that 5% of the file data will
Total
be
data.
the 5% of the total data. It means every time
Total data.
5% means there will be 20 nodes only. By default, there is 20 nodes.
Yeah, default strategy 5%. So default
Okay.
strategy 5%. Default is
Means
20 nodes.
we can increase or decrease the percentage of that thing.
Yeah, increasing auto scaling option is available. Auto scaling is there. Yes, auto
Okay.
scaling is available. Yes, depends on data. Auto scaling means see. So but data 100 GB, that case 5%. Suppose 200 GB, 300 more data getting here. That again because of the distributed strategy, 5 divided by 2 means around 2%. 2% of total data. Very big data is there. What happens? 2% of data distributing on multiple nodes. Now 2% means now how many nodes? Now it's like 50 nodes, right? In case of 20 nodes, now it's a 50 nodes. If data is
Yes.
more, that will be distributing on 50 nodes. Very big data file is there. Yes, in case of 20, it's a 50. Okay. Very big data file is there. Maybe chance of distributing onto 20, 80 nodes also. Yes, auto scaling automatically changes. Yes, Hadoop will change the strategy automatically. Depends on data. The Hadoop will change the strategy. Auto scaling option is available here. Auto scaling automatically changing that percentage. I think it's clear, right? Okay, default is 5%. Default is 5%. Okay. Some more data is there. Yes, even that reduces 2%, 1% like this. It's an auto scaling option. Okay, right? Suppose very small data is there, that case not 5% is here, even maybe 10% is taking care. The strategy default is 5. Okay, right? That's it. Auto scaling depends on data. The distribution changes. Depends on data. Small data, less number of nodes. So more data getting, number of nodes increasing. Yes, still more data, number of nodes. Yeah, see, as size of the file increasing, number of nodes will be increasing automatically. You understand here? As size of the file increasing here, number of nodes increasing automatically here. Number of nodes increasing. Okay. Yes. Now here, yes, how this Hadoop can handle big data file? See, this is node, right? It's a Linux computer. On top of Linux computer, Hadoop is running. On top of Linux base, Hadoop is running. On top of Linux, Hadoop is running, right? Linux file system. Yes, even Hadoop file also storing on top of Linux file only. Hadoop file also on top of Linux file. What is maximum size of Linux file? Yes, around 60 GB. 60 GB, more than files. Okay. Now 60 GB it can take. One node can take whatever 60 GB data file. 60 GB data file. Right? So 200 GB data file, it won't take. 300 GB data file, it won't take. Now what happens in Hadoop here? That 100 GB data file divided into multiple parts. Then how many 20 parts? Means 5 GB, 5 GB. That means on this node, how much data? Only 5 GB storing. 5 GB is not an issue. It can take, it will take 5 GB. It will take 5 GB. That file with 5 GB. Part 1, file part 2, file part 3, file part 4. So one file, multiple parts, dividing multiple parts and distributing it. Okay. So because of distribution logic, even very big file also, very large file also can be handled. So Hadoop can handle very large file also because Hadoop will break the file into multiple parts and distributing onto multiple nodes in cluster, distributing onto multiple nodes. Okay. Yes, this topic practically I will explain. Don't worry. Topic is there. Practically also that's how that distributing into multiple nodes. Yes, the big data file. Yes, how to process big data file. When you processing big data file, how the distribution strategy also practically we'll discuss. I'll explain very clearly. Okay. Just I'm giving overview now. Just I'm giving overview. In actual topics, we'll discuss very clearly all of this. Okay. Yes, next step. So this is about very large files. Hadoop can handle very large file also, but traditional systems can't handle. Traditional systems cannot handle here. Okay, right? Yes, next others. Backup and recovery. Yeah, interesting topic. Backup and recovery. Let us see. Backup and recovery. See backup. Backup. So first let us see about backup. Backup. Yes, backup. Traditional databases. Traditional databases versus Hadoop. Traditional database versus Hadoop. Yes, backup status in traditional systems, backup status in Hadoop. Let us see. Traditional databases. Suppose there is a database server. Database server. So database server. This database server data has to take daily backup. This is backup here. Traditional database. Maybe Oracle database or MySQL or something like this. Backup. Backup. There are two ways backup here. One is daily backup, another one is weekly backup. So one is daily backup. Yes, daily backup. As incremental backup. It's incremental backup. There are two types of backups here. Daily backup or incremental backup. Daily backup or incremental backup. Next, weekly backup. Another one is weekly backup. Weekly backup. Yes, it's a full backup. It's a full backup. Yes, full backup. So full backup jobs are running and incremental backup jobs are running here. Yes. Yes, I know that practically here. Practically worked here. So daily backup jobs running, weekly backup job running here. Daily backup job is incremental backup. So what is incremental backup here? See, incremental backup every day running that job here. Incremental backup. So why called as incremental? Reason is here. Suppose Monday backup taken. Monday backup taken. Next Tuesday backup will be append to the Monday backup. So it's increment, right? Increasing. Yes, next Wednesday backup will append to this. Okay, next Thursday backup will append. Next Friday backup will append here. Next Saturday backup will append like this. Appending all the right. Monday, Tuesday, Wednesday, Thursday, Friday, all is data. Sunday data. So everyday data appending to the existing data. So first Monday backup taken, so Tuesday data will be appended to this. Wednesday appending, Thursday. So increasing the data, right? So called incremental backup. Incremental backup is a daily backup. Right? Okay. Yes, weekly backup means only once full backup. So next is weekly backup, full backup. Yes, here incremental backup, daily backup, maybe yes, just small data, matter of 15 to 20 minutes. Yes, our small data jobs are finishing within 15-20 minutes. So big data is there, small data, incremental backup, small data 15 to 20 minutes. Small data. So big data is there. Big data around 1 hour taking this is. Big data around 1 hour. Around 1 hour. Okay. Yeah, this is my practical experience I'm saying here. If it is small data, 15 to 20 minutes, the backup will be finishing. So big data. Small data means if it is like GBs of data, 15 to 20 minutes enough. GBs of data. So but terabytes of data, taking a lot of time. Terabytes of data. I can generate, yes, lot of data, right? Lot of data. Okay, yes. So incremental backup, this is 15 to 20 minutes, maybe 15 to 20 minutes, like 10 GB data, 5 GB, daily generating some small, yes, small transactions, generating 5 GB data, 10 GB data in a company. So for 10 GB backup data, 10 GB backup, 15 minutes enough. If it is 10 GB backup, 15 minutes enough, not more than that. Okay. Suppose 100 GB, 1 hour required. 150 GB minimum 1 hour required. 10 GB data, 15 minutes enough. Okay, right? Suppose 50 GB data, around 1 hour required. 1 hour required. Okay. Yes. That is the case of incremental backup. Weekly backup. Yes, weekly backup. This is yes 2 to 3 hours. 2 to 3 hours will be taken. Yes, weekly backup is a whole week data, right? It's a 2 to 3 hours. Okay, right? 2 to 3 hours around this is. Sometimes 2 hours, 3 hours. Small data case. Big data. Yes, if it is big data, we are running for sometimes 12 to 13 hours. Yes, I have seen many jobs running for 12 hours. 12 hours, 13 hours, 14, 15, 18 hours also. It's very big data jobs. I have seen 18 hours also. Okay, today started, tomorrow ending. Today started, tomorrow ending. 24 hours has taken. This is the big data jobs, right? Yes, now, okay, fine. Backup jobs, okay. So the jobs are running taking backup. Suppose any incremental backup failed, incremental backup script is failed, the DBA has to fix that issue. Yes, relaunch again. Yes, DBA support. Yes, why 24/7 DBA supports the backups? Yes, issue they have to fix all the issues here. Any issue raising here, the DBA guy, the DBA resource will fix the issue and launching that backup. Suppose weekly backup job failed here, so 12 hours running. Job running is for 12 hours. Okay. Suppose after 10 hours of backup, it's failed. They have to relaunch again here. Okay. Yes, after 10 hours, if failed here, they should fix that issue and it should be relaunched again here. It's a risky task, it's not easy here. Very backup task is very risky task. Okay, right? Yes, sometimes in backup, like at the middle job failure, sometimes here data loss, sometimes duplicate data getting, lot of issues with this. Lot of issues. So that DBA has to resolve everything. So there's a lot of risk in taking backup here. Yes, in traditional systems here, lot of risk. Everything is manual. It's a manual backup here. So that script has done, the script will be taking backup, right? It's a risky task. Yes, in traditional systems, backup task is a risky task. Many DBA resources have to work here. It's an expensive. It's an expensive. Right? Okay. So about traditional system. Same thing in Hadoop. What happens here? Hadoop backup. Let us see about Hadoop backup. Okay. Yes. Let us see about Hadoop backup. In case of Hadoop, what happens here? Let me take Hadoop cluster. Hadoop cluster. In case of Hadoop, what happens? Let us see. Hadoop. Yes, cluster here. Hadoop. Suppose some file loaded, some data loaded, some data loaded. Okay. For every data, Hadoop will maintain 3 copies. Yes, in Hadoop, there's a concept of replication strategy, replication policy here, replication factor. There's a concept of replication factor, replication factor, replication factor, replication factor. See, default replication factor, default is 3. Means for every data, it will create 3 copies. For every data, Hadoop will create 3 copies. Suppose when you loading file 1 with 100 GB data, that creates 300 GB data. That generates 300 GB data. Okay, 3 copies. 3 copies on 3 different nodes, not same nodes. Suppose if it is same node, no use. On 3 copies on 3 different nodes. 3 copies on 3 different nodes. 3 copies on 3 different nodes. Okay. Now default replication fact is 3. So 3 copies on 3 different nodes. Okay. Next, minimum replication false is 1 here. Max replication fact is 5. We can change it. Default 3. Default replication factor value is 3. Replica means copy. Replica means copy here. Default 3 copies. For every data, it will create 3 copies. Minimum 1 copy. Okay, next maximum 5. Okay. Yes, I'm explaining. Just wait. You asked me about replication factor, right? Naveen, about replication factor. Yeah, same. Just let me finish. Here, Hadoop, there's a concept of replication factor. Replica means copy. Replica means copy. Default replication factor value is 3. Means 3 copies. Minimum 1. Maximum 5. So default 3 is available that we can change. We can configure. We can change to 4 or 5 or 10. We can change it. But I should not require default 3 is enough. 3 is enough. Now the default replication factor is 3. Suppose when file is loaded. Whenever a file is loaded here, it will generate 3 copies. For the same data, it generates 3 copies. 3 copies. Suppose here first copy, here second copy, next somewhere third copy. For every data, it generates 3 copies. 3 copies at 3 different locations. So this is first copy. Suppose maybe second copy, another node. Third copy maybe another node. 3 copies like this. 3 different nodes. I think you understand, right? 3 copies and 3 different nodes. I take 3 copies and 3 different nodes. For example, here, suppose 100 GB. In our case, 100 GB data, right? 100 GB data, then what? 5% of means 5 GB. So 5 GB, next to 5 GB, next to 5 GB. Okay, right? Yes, like this totally 100, right? Next to 5 GB data. Yes, next to 5 GB data. Next, like this 5 GB, 5 GB, right? Totally 100 GB, right? Yes. What happens here? For the first 5 GB data, it will create 3 copies. First copy here, second copy here, third copy here. Next to 5 GB data also 3 copies. Next to 5 GB data also 3 copies. Next to 5 GB data also 3 copies. For every 5 GB data, it creates 3 copies. And storing on 3 nodes. Totally how many here? 20 multiplied by 3. How many here? 60 nodes. Finally, that becomes 60 nodes. Is it clear? 3 copies. Okay. So 5 GB data on the node 1, maybe next node, next node. Suppose next to 5 GB data, next maybe some other 3 nodes. Next to 5 GB data, some other 3 nodes, like this. All this data distributed and multiplied in cluster, 3 copies. Every data becomes 3 copies. Suppose distribute like a 5 GB, 5 GB, 5 GB here. This 5 GB 3 copies creates, storing on 3 nodes. Next to 5 GB 3 copies creates, storing on 3 nodes. Next to 5 GB 3 copies creates and storing on 3 nodes. Next year 3 copies like this 100 GB like this. You understand this is? Everyone, is it clear?
Yes, sir, it is clear, but I have one question. Since we are just replicating this, simply we are just wasting the resource. Means unnecessarily we have 5 GB.
Yeah, I'll agree with you. Wasting hardware. You saying that wasting hardware. That's okay. I'll agree with you. See,
Correct.
in traditional systems, what happens here? Traditional system disk. In traditional system, disk. When using disk here, we should use RAID disk. Traditional systems will use RAID disk. Okay, RAID disk. Traditional systems will use RAID disk. When come to Hadoop here, Hadoop using cheaper disk, commodity disk, commodity means cheaper disk. Just it's a commodity hardware, cheaper hardware. So why RAID disk required in Hadoop? Yes, in case of traditional systems, traditional systems, yes, like Oracle database. In case of Oracle database, disk RAID disk. Why RAID disk? Some disk failed. So RAID disk, no loss of data. Suppose commodity disk means in our computers we are using some disk, right? It's a cheaper disk, cheaper hardware. Our computer disk, suppose disk failed, loss of data. Our data 100% loss if it is failed here. Okay, but RAID disk even failed, we can get back data. We can restore that data here. So all the traditional systems using RAID disk. RAID disk, this is 10 times costlier. 10 times costlier. 10 times costlier than this commodity disk. Yes, in Hadoop we can use commodity disk. Suppose one disk is failed, second copy, third copy, 2 more copies are right. For that reason, 3 copies. So one disk failed here. Yes, second copy, third copy, 2 more copies means backup copies available here. Hadoop will maintain the backup copy for every data automatically. So one disk failed. Yes, even that commit disk failed, no loss of data. 2 more copies available here. 2 more copies using that data. Okay. Yes, in Hadoop, this read disk is not necessary. We can just commit disk, right? With this, what happens here? Cost will be reducing here. My cost will be reducing. Right? Okay. Next, one more thing here. In traditional systems here, how many copies maintaining? In suppose traditional system, how many copies? One is live copy, another backup copy. Even for traditional systems, also 2 copies required. You understand, Rahul? Hello.
Yes, sir. Yes, yes, I understand.
In traditional systems also 2 copies. One is live copy, another backup copy. In traditional systems, how many copies? 2 copies. In Hadoop, 1 extra copy. That's it. Nothing is there. Okay. In Hadoop, just 1 extra copy we are using. In Hadoop, just 1 extra copy we are using. That's it here. In traditional systems, one is live copy, another one is backup copy. Yes, in Hadoop, all 3 copies are live copies. All 3 copies are live copies. Why live copies? I'll explain now. All 3 live copies. See, in traditional systems, one is live copy, another one is backup copy. Means online copy, offline copy. In case of traditional systems, when come to Hadoop here, all are online copies. Means yes, live copies. Why live copies? I'll explain now. Just wait. That makes a difference. Yes, here cost. Yes, that disk cost for next copies, that makes the difference. Right? Okay. So here Hadoop hardware is not expensive. Cheaper hardware here you can use because 3 copies are maintaining here. Okay, but yes, in Oracle database, the disk is costly 10 times more expenditure than this. That there it differs. Okay. Yeah, 1 second. Sai asking something. Naveen, 100 GB file want to insert, then it will definitely 3 copies of data. Yeah, definitely 100 GB wants to insert, then it will with 300 GB, 100 GB becomes 300 GB. 100 GB converts into 300 GB. 300 GB data. Okay. Yes. Now let us see backup. Yes, when come to backup here, for every data copies we maintain this is. For every data, automatically 3 copies. Okay. Suppose first node disk failed, no worry. Second copy is available, third copy, so backup copy is available. So in Hadoop, manual backup is not necessary. See what I mean to say here. In Hadoop, manual backup is not necessary. In traditional systems here, by running script, weekly backup, daily backup, by running script, we'll take the backup, right? Backup. Okay, by running script, manual scripts. Okay. But in Hadoop, not necessary. In Hadoop, that backup is not necessary. Hadoop takes care of that. Manually taking backup is not necessary here. Hadoop will create 3 copies automatically. Suppose if you want more than 3 copies, yes, it can. That you have to configure. So how to configure, I'll explain later. Okay. So manual backup is not necessary. That risk is don't have here. Here, no risk in taking backup here. There is one more. Big data challenges. In big data challenge, backup is the challenge. In traditional systems, here, backup. Traditional systems, big data backup here. Risky task. Many DBAs have to involve into this, right? It's a risky task. Okay. If it is Hadoop, no risk. Hadoop takes care of it. So extra resources, nothing, no one required here. No DB guy required here. Yes, Hadoop takes care of that backup copy automatically. So this is solution from the Hadoop here. Backup task. With Hadoop, automatically backup here. So manual backup is not necessary. Yes, fine. Next, recovery. Yeah, this is one of the important topic, recovery. Interesting also. Recovery task. What is recovery here? Recovery. Yes, now let us see traditional systems. First, let us see about traditional database. Suppose this is traditional database. Okay. Suddenly this database server failed due to some reasons. Various reasons here. Database server crashed or failed. How to recover that? What is the recovery process? Okay, traditional systems, what is the recovery process? Yes, traditional databases. Yes, traditional databases. Traditional databases. So what's the recovery process? Let us see about recovery process in the traditional database. Recovery process. So suddenly database is failed. Right, okay. Yes, DBS getting alert message. So time database failed down or something, some message. On receiving message, they will check it here. Database server failed, it's not working. What's the problem? They have to identify the issue. After identifying issue, they have to rebuild the server. Completely server failed. That server has to be built. Okay, see, here database is running here, suddenly failed. Of course, already backup will be there. There is a backup copy here. 1 second. So backup disk, you say backup disk. Backup disk. So daily taking backup. Yes, in backup disk, the data is available. Daily taking backup. In backup disk, backup data is available. Okay, this is filled. This is hashed. Now we should rebuild the server. The server has to rebuild. Okay, right? Yes, sir. 1 second. In real time, what happens here? For everything, they will maintain two servers. First server and second server. There are two servers. For every data in real time, production environment here, operational systems maintaining two servers. One is main server, another is swap server. So main server, this is main server. So main server. Next second one, swap server. This is swap. Swap. Main server and swap server. Suppose application, for example, app. Some application, some app is working with this database. Okay, some application work with database, right? Now this main server, swap server kind of same data, same data. Main server and swap server, same data. Whatever data generating here, that will be replicating to this, right? So main server and swap server. Okay, right? Suppose main server failed, this application will be swapping to the server automatically here. Like that, we'll set up this. Real time, what happens? This is failed here. Now all the application will be swapped into this server here, right? Now application using swap server, right? Suppose this swap server failed, loss of everything, application not work here. Right, okay, now we have to record this server. Swap is, now currently we are using swap server, right? But version server has to recover. Suppose version class server not recovered, only swap using continuously. Suppose swap fails, no alternative, right? That means we should recover the server. Now how that recovery here? Now let us see traditional database, that recovery here, recovery process. In recovery process here, first hardware team, yes, see, any server crashed, any server failed here, team, the DBA team lead will prepare one schedule. Okay, so and so team, so and so time working. Next team, next time. Next team, next time. They will prepare one schedule and will forward to all the teams. All the teams, as per schedule, they will start working on this. Okay, so before working on this here, first, yes, first you will get the approval. The team lead will get the approval, nothing but called RFC, request for change. Because in the production servers, request for change, RFC. See, for every data center, there is a director, technical director. Okay, the technical director has to approve to record this database server. It's a production servers. To work on production servers, compulsory approval required. Without approval, no one can work here. So for this raising RFC, the team lead, the DBA team lead, yeah, this is practically I did everything. So DBA team lead, yes, will raise RFC. So RFC. So after raising that RFC goes to manager queue. Manager queue. From manager queue, the director queue. Technical director. Right? So once approved by technical director here, then work starts. In that work, first hardware team come to picture. Hardware team checking for any hardware failures. Yes, hardware team, they will check for hardware failures. Suppose if any hardware failure, they will replace the components. Maybe motherboard failed. Suppose a old computer, sometimes here database of this maybe very old computer, old system, they will replace. They will purchase new server completely here. Yes, discarding that scrap, they will send to scrap care, then scrap, then they will purchase new computer. So hardware team, they will take new computer. Okay, they will, yes, they will make it ready here. Now hardware is ready here. Now hardware ready here. What is next step? Linux team. Linux team will come to picture. Now Linux team will install Linux on the computer. Linux, they will install Linux here. After install Linux here, they will update OS. Okay, so there are some prerequisites for database. They will run all the prerequisites like updating OS. Next, installing some SH like this. There are some commands. Okay, yes, they're preparing Linux base. So once Linux OS prepared, ready here. Now DBA team will come to picture. Now DBA team will install the Oracle database on Linux base. Oracle database on Linux base. One second. Before DBA team, this networking team. Yes, networking team will place the Linux system into company network. Okay. Yes, they will configure the IP address. They will unblock some port numbers. Okay, it has to listen for some port numbers. Unblocking port numbers, some firewalls, right? Unblocking firewalls, and next configure IP address on this, right? Yeah, they will put network. So networking team will place the Linux system in network. So first hardware team, they will build the hardware. After building hardware, Linux team will set up the Linux base here. Networking team will put the Linux computer network here. Once company network. So once the server in company network here, now DBA team will come to picture. Now DBA team, they will set up database. Database setup means various steps, like they have to time taken the DBA team. First they will install Oracle database. After they have to create instance. After creating instance, schema, some login schema has to create. After that, they have to build all the database objects. Okay, database objects like tables and views, so many kind of things. They have to build everything. So once built, now database is ready. Database is ready here. Once database, that means the system is ready. Once that system is ready, suppose system, yes, system is ready. That new system is ready. Once new system is ready here, yes, already backup data is already. Once new system is ready here, they will take the backup data and restoring that newly created tables here. Restoring that backup data, see the backup data taking regularly. That backup data restoring to new server dishes. So once restored here, server come to live. Server come to live. So once the server come to live here, next is application support team. Yes, application support team. Application support team will configure applications for the server. Will configure application for the server. Right? Now currently applications are using SAP server. Right? Now what happens here? Same these applications they will configure to the server. Now this come to picture. Okay. Now currently applications using SAP server. Right? SAP server. Once build, yes, once this so once this is recovered, once the server recovered here, they will configure all the applications to this main server. Once you configure, now applications moves to this main server here, from SAP to main server. Again using this main server. But again, now they always act like a SAP here. Suppose whenever this is failed here, moving to SAP. Again, this is now moving to SAP like this. That's it here. Suppose SAP server failed here, that case main server. Okay, so before failing SAP server only, this main server has to recover here. Recovery process. So recovery process, hardware team, Linux team, networking team, DB team, application support team. This much of teams have to involve many resources. Around 10 to 12 guys. From every team, 2 members. So 10 to 12 members. Yes, maybe taking for 24 hours. That will be taking 24 hours. Or sometimes, yes, I have seen many in my career. Okay, 24 hours, 48 hours, sometimes 72 hours also. Sometimes what happens here? Suppose server build is done. Server complete, restoring complete, everything completes. At the end, last minute server again failed. last minute due to little bit mistake here, maybe failing. Again, 72 hours has to work. Due to some mistakes, failed. Again, 72 hours. Yes, lot of risk. Yes, I have seen many this kind of things. Okay, so this is about traditional systems. In case of traditional systems, recovery is like this. Lot of risk, maybe taking for 3 days or 4 days. Any server crashed here, any server failed here, to recover the data here, maybe taking 3 to 4 days of time. Next, wasting of many resources is an expensive. It's an expensive. Yes. Next, come to Hadoop here. Hadoop. In case of Hadoop, suppose any server failed, what recovery process? Let us see. What recovery process? Suppose here this data node 1. Yes, this is first copy, second copy, third copy. There are 3 copies. Same data, 3 copies available. Suppose suddenly this is failed. Then what happens here? Then how name node knows this data is failed here? For this, there is a concept of heartbeat mechanism. Here there is a heartbeat mechanism here. Hadoop maintains heartbeat mechanism. Heartbeat mechanism. There is a heartbeat mechanism. Okay. In Hadoop there is a heartbeat mechanism. Right? Yes. Heartbeat interval is 3 seconds. Interval value is 3 seconds. 3 seconds. 3 seconds. For every 3 seconds, now this data node sending heartbeat in name node saying that I am alive. I am alive. Okay. So simply data node saying that I am alive. Sending heartbeats name nodes. Every data nodes. Suppose Struts is having 1000 nodes. All the 1000 nodes sending heartbeats name nodes saying that I am alive. I am alive. I am alive. Every data nodes sending heartbeats name nodes saying that I am alive. I am alive. I am alive. Right? So heartbeats. Sending heartbeats. Right? Okay. Suppose this node is failed due to some reasons. Yeah, reasons could be network down, sometimes network down, sometimes power failure, sometimes hardware failure, sometimes software failed. Maybe inside of this, maybe Hadoop software failure or OS failed. Reason could be hardware failure, software failure, power failure, something else. In that case, it won't be sending heartbeats, right? So name node will not be receiving heartbeats. That is what happens here. Okay. See name node expecting for heartbeats for every 3 seconds from all the machines here. Yes, name node expecting for heartbeats from all the data nodes in the cluster. Suppose if any data node not giving heartbeats, then what happens? For example, here this node failed. So once it failed, it won't give any heartbeats. If not giving heartbeats here, now name node in reverse. In reverse, check for the availability of this node. Is it available or not? Reverse. First, if not getting expecting heartbeats, if not getting heartbeats here, in reverse, it will check for the availability. So first time if not available here, then checking for second time. After 3 minutes, checking for availability. Second time is not available, then waiting for 3 minutes. Again after 3 minutes, checking for availability. 3 times checking here. 3 times, totally around 10 minutes. After third time is not available, here, then name node will come to some conclusion. Here. That node is down. That node is failed. Data node is dead. Okay. So name node will come to some conclusion that that node is dead. So once decided, what happens? Once decided node is dead, what happens here? In that case, what happens here? See first copy node, second copy node, third copy, right? Third copy. Okay. So first copy node is dead, right? Same copy is here and here also. Now that case, now name node just give the instruction to second copy node. Name node just giving instruction to second copy node, the second copy node, right? Name node giving instruction second copy node to create another replica for same data, create another replica in another node, maybe some X nodes, different nodes, maybe different nodes. This is different nodes on this node, right? Now here, whenever this is failed here, so when yes, it's a dead. When this node is dead here, for the same data, second copy available, third copy is available. Now name node will give the instruction to second copy node. Name node gives the instruction second copy node to create replica for the dead copy, to create replica for dead blocks on the other node. Now how many copies here? So this data second copy creating and making one more copy here. Yes, placing here. So this copy creates and transfer this. Now how many copies here? Here one copy, here another copy, here another copy. Okay, so this one copy. Yes. So initially here, this is one copy that is failed. Second copy, third copy. First copy, second copy, and third copy, right? So first copy fails. Whenever failed here, name node giving instruction to second copy node to create replica on the other node, right? Then how many here? One more copy means three copies. Three copy, right? So this node failed. This node failed. This node failed here. Then name node giving instruction to this copy node to create replica on another node here. To create replica on another node, maybe some other location. So how many copies? This is one copy, another copy, another copy. So that is recovering automatically. Any system is failed, any computer failed, that is recovering to another node automatically. Automatically, right? But in traditional system, what happens here? Manually performing all this. Manually recover, right? Yes, different various teams come to picture. Manually recovery, time taken, expensive. Right, okay, lot of expensive here, time taken here. Okay, time taken and expensive is right. Lot of risk also. But when come to Hadoop here, no risk, no, yes, with no time, with 10 minutes, only 10 minutes. Within 10 minutes, that will be replicated another node here, only 10 minutes. So this node is failed. See, 3 times checking, first time checking, after 3 minutes, second time checking, after 3 minutes, third time, totally 10 minutes. After 10 minutes, immediately starts instruction. Okay, once node identified as dead, immediately starting that recovery process. Okay, so any copy failed here, that recover to another node automatically. The second copy moves to another one here. Second copy becomes one more copy here and placing here, right? So name node make sure that always meeting replication of policy here. Replication strategy is 3. Replica 3, right? So always 3 copies. Always 3 copies. Okay. So name node make sure that always 3 copies maintaining the cluster. So any node failed, that is recovering automatically. Okay, manual recovery is not necessary, right? Yes, it's an excellent, right? This kind of things excellent here. Yes, in traditional system don't have this kind of facility here. In Hadoop, yes, it's very interesting feature. This excellent feature in Hadoop here. Automatically that node is recovering. Okay, yes, I have seen practically that recovery of that data. Okay, that I have seen practically. That's the reason I'm saying this is okay, right? Yeah. So this is about recovery task. Okay.
Sir, I have one question.
Yeah. Tell me.
The question number 1 is it any thumb rule in any scenario who is working maybe in healthcare or maybe in any industry? It is a thumb rule there should be 3 copy of replica in any node.
Yeah. Default is 3 copies. By
Okay.
default, once Hadoop installed, by default is 3. Okay. If you want to change, you can change it. You can make it 4 or 5. There's no
Okay.
thumb rule. There's a hardened password here. You can make it 4 or 5.
Oh,
Okay.
sure. Thanks.
Default is 3. Default 3. You can make it 4, 5 also. Once again,
Okay.
why 3? I'll tell you. Why default 3 key given? That reason also I'll tell you. Why 3 given? I'll tell you. Why 3 copies? For that reason is there. Why 3 copies? Suppose first copy failed. Then 2 more copies are right. 2 more copies are available. Now try to access second copy. But second copy already using by some other job. Then that case go for third copy. Right? So 3 copies. One is for the failure case. Okay. Second copy shareable, already sharing with some other job, that can go for third copy. Suppose third copy also sharing with some other job, simply put in waiting state. The job goes to queue. Simply that's it here. That's the reason 3 copies. One is to handle failure case. Another one is to handle copy busy. That copy is busy with some other job. Then go to third case. That's it here. So using this one, right? That's it here. That's the reason 3 copies. One failure case, another one utilizing this. That's it here.
Hello,
Okay.
sir.
Yeah, tell me.
Sir, for every time the 3 copies at the same time, in the what is that? Sir, once more. Okay. Sir, for every time. ఇప్పుడు ఈసారి కాపీ చేసేటప్పుడు ఈ జాబ్ చేసేటప్పుడు ఈ నోడ్ 1 నోడ్ 2 నోడ్ 3 అనేది ఎట్ ఏ టైమ్ లో సేమ్ ప్యారల్ గా డేటా ఇన్సర్ట్ అవుతుందా?
So this is copy can fail అవుతుంది. దీంట్లో డేటా ఉంటుంది కదా. This node
Sir,
node
what is the question? Even I'm sorry for that. Even I want to also understand. I'm sorry. Please don't mind.
yes sir. Yeah, question was yes, sir. Every time of failure, will it copy or not? That's your doubt, right, Naveen?
No, I'm saying that if there is any job at the time of running, if the data is inserting in the node 1 and node 2 and node 3 at the same time or not. There are three replica, right? For the 3 replicas, at a time the data will be inserted into three nodes.
Okay. Yeah. Okay, fine.
See, if the node 1 is getting failed, then node 2 and node 3 is running.
Yeah, job. What is the job? Data loading job, right? Loading
Yes.
Data loading. Suppose first copy loaded. Okay, for the same data, second copy loaded. For the same copy, yes, at the time of loading, third copy failed. That removes remaining 2 copies also. Once 3 copies are successfully loaded, job completion. Is it clear? First copy inserted, second copy inserted, third copy. 3 copies are completed, then pipe will close. Okay, what happens here? First data comes to first node. From this, it will create one copy, one pipe will create. Pipe, nothing but socket will create. From this, another socket creates here. So first data, suppose here, first packet come to this, packet filling. That packet goes to this, same copy creates here, same packet goes to, right? Like this, all suppose 5 GB data loading. All the 5 GB data transfer to this and pass this. Once 5 GB data transfer to all the 3 computers successfully completed. Suppose anything fail, yes, it will take back again here. Okay, suppose so here failed, but this is failed. This is failed. That get discarding that copy again we start. Again piping creates. Again piping creates with another node. Is it clear now? Hello.
Sir, I am clear.
Yeah, that piping comes, nothing is there. Once data comes, the data transfer to the pipe. Same data transfer is right. Once 3 copies are completed, then the job is completed. That's it here. Okay.
Sir, actually, I have one question here. See, suppose the name node itself get failed. In that scenario, what will happen, sir?
There, wait. Time is there, not yet completed the topic. This will discuss.
Sure. I'm sorry. Sorry, please.
Yeah. So this is fine. So this is a case of recovery. So that any node is failed, that recovering automatically, right? So this is a case of data node failures. Okay. Next level. Suppose name node failed. Name node failed. Complete cluster is down. There is no alternative for this. That you can work on second version. Second version of Hadoop, 2 name nodes available. So first name node is failed. There is a second name node working for this cluster. Okay, highly available name node. In second version, why second version released? Main purpose of 2 name nodes. Suppose this name is 1.x version. In Hadoop 1.x version, disadvantage name node failure. Name node is a single point of failure. If name node is failed here, complete cluster is down. Whole cluster will not work. Not only if even down, cluster is down here. If no name node is down, cluster is down here. There is no standby for this. This 1.x version disadvantage that you can overcome second version. In second version of Hadoop here, we have the two name nodes. There are two name nodes. Okay, suppose this node is down, this become active. Active name node and passive name node. There are two name nodes. Okay, so this is down, then this will be serving the cluster. That's it here. Is it clear? Rahul.
Sir, yes, sir.
Yes,
sir.
Second version. Yes, this is just only I'm giving overview. Since last 2-3 days, I'm giving overview of Hadoop. In Hadoop, not attended here. Okay, one by one topic we'll discuss once again. So once again with real-time cluster, I'll explain practically. Right? Don't worry. Just is only overview I'm giving here. So what is our overview here? What is our topic here? Big data challenges. Topic is big data challenges. Okay. So for big data challenge, what is solution from the Hadoop that we are discussing simply? Okay. Data storage. Yes, Hadoop can store unlimited data. There is no limit because of any number of nodes continuously can add it here. Data processing, even big data also can be processed within a short time because it's a distributed data processing. High-end hardware not required with Hadoop here because backup copies. Next, Hadoop can handle very large files because of splitting file into multiple parts, splitting file into multiple blocks, multiple files. By splitting, it can maintain very large file also. Backup and recovery. So Hadoop will maintain 3 copies every time. Okay, suppose any copy failed that recovered automatically, that copy recovered automatically. That copy recovered automatically. Right, okay. Yes. 1 second. Yes, actually in actual topic, yes, after installing Hadoop here, after Hadoop setup, we'll be discussing clearly that architecture. This is real-time architecture. In real-time Hadoop, this cluster, Hadoop cluster will be like this. There is a client nodes, mask nodes, slave nodes, lot of various things. The practical explanation is, I'll explain very clear that time here. After finishing Hadoop setup, okay. After finishing Hadoop setup, this topic starting here. So that time it becomes very clear. Yes, we'll set up the Hadoop. Next, we'll practice for 2 days. After practicing for 2 days, I'll explain this one here. Real time, this complete real time setup, I'll explain. Okay. Now explaining here, after at the middle of the course, I'll show the practical setup. Taking 6 computers. Yes, in my laptop, I can take 6 computers. See VirtualBox. 6 computers like 1, 2, 3, 4. 2 more computers I can add it here. I can set up on 6 computers. 6 or 8 hours I can do. It's a yes, my system is 16 GB RAM, 6 computers multiplied by 2. So 12 MB RAM. Yes, 12 GB RAM. Remaining 2 GB using for Windows OS. Yes, I can make it 6 or 7 computers. I'll set up at the middle of the code. That is for every batch I'm explaining at the middle of the code. The cluster setup. Practically I'll explain. Alright. Yeah. So next, yes, disaster management, disaster recovery. Suppose any natural disaster can gets here. Hadoop get 3 copies, right? That recovering automatically here. Even natural disasters, no problem here. That Hadoop records the data automatically. Auto recovery option is all right. Okay. Yes. Right. Yeah. That's all about all the Hadoop challenges. Yes, big data challenges and solution from the Hadoop here. Traditional systems are not in a position to face all the challenges. To face all the challenges, Hadoop is the best solution. Hadoop provides best solution for all the challenges. Yeah, that's all. Overview completed. Overview completed. So next topic is Hadoop setup. Before going for Hadoop setup, first of all, you have to set up the Linux OS. Okay. So next class, taking on Monday. Monday, same your time, 8 o'clock. 8 o'clock, I'll take Linux setup. So Monday Linux setup, after finishing Tuesday Hadoop setup. Next Wednesday working with Hadoop 1.x version. Thursday, Friday, up to Friday working with 1.x version. After finishing next Monday second version. I'll be moving the second version. I'm not going to explain 1.x version. 1.x version only for introduction here. Introduction. I'm introducing 100x version. Immediately next week, moving to second version. Completely our applications, our topic, and everything is on second version of Hadoop we are going to discuss. Yes, here question is why 100x version I'm explaining here. Reason, you should know what are the disadvantages from the 100x version. If you worked practically on 100x version, suppose working for 2 to 3 days, you can understand what are the disadvantages. Yes, to overcome 100x version disadvantages, second version adverse release here. To understand the disadvantages only, I'm explaining for 1 week 100x version. Otherwise, directly I can switch to second version of Hadoop. Why wasting of 1 week time for me? Okay, but I'm not a commercial. Because here, if you know the 100x version, they can understand. Simply here, I'll explain what disadvantages of 100x. These are the, yes, these are the so and so disadvantages for 100x version. To overcome the second version release here, I can explain that simply. Simply, I will make it note here. I will move to second version. No, that is not my way here. I have to show practically. Okay, these are the 100x version disadvantages. I'll show practically. After that, I'll move to second version of Hadoop. So next week completely we are going to work on first version of Hadoop. After finishing that week, second version starts. From second version onwards, 45 days. From second version onwards is a 45 days topic. Totally 50 to 55 days. That's it here. Right, okay. Yes. Any doubts? Yes, guys. If doubts, let us find out next class on Monday. Yes, 1 second. Please ping your emails. Okay. Yes, not here. Yes, in group in WhatsApp. Okay, 1 second. Just a minute. Yes. Yes, in WhatsApp, just ping me your emails. I'll share this. Till now, what I discussed. This is a fourth video, right? First video not uploading because that is very introduction only. It's a fourth video. Yes, today I'm creating drive night. I will upload this. I'll share it. Saturday, Sunday, 2 days you have the time. You can watch it. Saturday, Sunday, 2 days time is available. Watch it. Yes, be ready by Monday. Monday will start working. Is it okay?
Sure. So, sir, what you would like to have the practice in this weekend? So, what do you suggest so we can do from our side, sir?
Weekend, yeah. My suggestion is follow the recording. Just go to recordings again here. I will be sharing recordings. Yes,
Okay.
just share your email ID on my WhatsApp. Share your email ID. I will share all the videos, last 4 videos. Just you watch all that 4 videos. Okay. So once you watch, you'll get some idea. From Monday onwards, we are going for Linux setup and Hadoop setups. Okay, right?
Sure.
Yeah. Any doubts? If no doubts, let us find out. So next class Monday at 8 o'clock sharply, 8 to 9:15 our class. Right? Okay.
Sure.
So attend 9:15 or second session also you can. 2 sessions you can attend 2 to 3 days. No problem. No issue. Otherwise, just videos enough. You can go through videos. In videos very clearly explained. Right? Okay. Daily live videos, not old videos I am sharing here. Last 4 classes videos I will share you. Live videos. Right? Okay. Yeah. So thank you guys. Let us find out. See you on Monday.
Thanks. Thank you so much, sir. Have a weekend.